All right, subtraction. Again, you guys told me, hey, I'm not going to get bigger. I'm going to get smaller, and that's absolutely what's going to happen. So if I have A equal to B, C equal to D, just like I did yesterday, subtract, just like addition, guess how many pairs of equal quantities you need to subtract? 2. I have 2 here. Somebody give me a true statement based on not addition anymore, but subtraction. That would be true, and I'm going to assume A and B are the bigger segments. Okay, A and B are the bigger segments, so you don't get a negative length here. So what would be true here? Here we go, Paige. A minus C equals B minus D. That is a correct statement by subtraction. Or what else could we write? A minus D is the same as B minus C by subtraction. All the rules still apply. Still need 2 pairs of equal quantities. All right, let's actually throw it into some geometry now. Angle DAC, everyone see that angle? It's a straight angle. And it's equal to the measure of ECA, which is also a straight angle. And I also tell you 1 is equal to 2. Can you mark that on your diagram? Get in the habit. Whatever you see in your givens, mark right away on your diagram. It's kind of hard to mark the straight angles congruent, but we can at least mark angle 1 and angle 2 congruent. And I'm asking why 3 and 4 are congruent now. Why 3 and 4? So ask yourself right now, guys, you are going from DAC, this angle right here, which is how much? 180, right? To angle 3, and you're going from ECA, which is also 180, to angle 4. Are you getting bigger or smaller with your angles? Smaller. So unlike yesterday, now I have to subtract. Okay, I have to subtract. Before I subtract, how many pairs of equal quantities do I need? How many did I give you? So that must mean in statement 2, I can subtract. But what should I be subtracting here? What do I subtract from each other to get to 3? What do I subtract from each other to get through 4? Maggie, go ahead.
The measure of angle DAC minus the measure of angle 1
Good.
equals the measure of angle ECA minus the measure of angle 2.
Looks good to me. Everyone agree? I take DAC and get rid of 1, I get 3. And if I take ECA and get rid of angle 2, I got angle 4 left. Perfect. And that's by subtraction. That's not what I asked. Just like yesterday, I asked for angle 3 to be congruent to angle 4. But what is another name for DAC minus angle 1? Angle DAC minus angle 1? Angle 3, yep. And the same thing applies down here. ECA minus angle 2. That's the same as angle 4. And we called that yesterday substitution, yep. Okay, no big deal with the subtraction yet. No big deal with subtraction. Okay, here you go. Don't be confused by this. I put the givens in the proof already. All right, that's what I'm asking. Hey, this is what I'm asking you to prove right here. Not what's given, that's what's proved. Your givens are in your statements reasons already. Okay, so go ahead, mark it on your diagram right now, what I put in the givens. So DF, longer one here. DF is congruent to BE. Those two, I'll do a different color so we can see. Perfect. Okay, look at those 2 given segments and look at the proof statement. I'm going from DF to DE, smaller or bigger? DF to DE, smaller or bigger? Smaller. BE to BF, smaller or bigger? Smaller. So automatically I know I have to subtract, but there's a problem right now. I cannot subtract in statement 2. Why not? What did I give you? Just 1 pair, right? You need 2 to be able to subtract. So we're going to have to do some investigating here and find out what should I be subtracting from DF and BE to get DE and BF. All right, take a look at the diagram. Everybody, take a look at the diagram right now. Figure out what must I subtract from those 2 bigger segments to get to the 2 smaller ones. And you guys are finding out, what do I need to subtract? EF both times, right? EF both times. So, and what do I know about EF and EF? They are congruent to each other based on which property up here? That is reflexive. Yep. Now that you have two quantities, go ahead and subtract. All right, go ahead and subtract. I'm not going to start asking people anymore because I think you guys are getting the hang of this. DF minus EF equals BE minus EF by subtraction. And then substitute in DE and BF. I usually put what for the last step? I just whatever matches the proof statement. So I am not a stickler for going between equals and congruent. So, all right, how you guys feel about subtraction? Okay, there's your quiz right there on Monday. Quick quiz. There's your quiz. What I'm going to show you next is a little bit more difficult, and I didn't put on the quiz. We all good? Questions? Okay. Before I get into the next one, which is a little bit different, it's not addition or subtraction. I got a couple questions for you guys. First question, everyone doing all right today? Big weekend plans, I'm sure? No? Okay. I didn't think so. Okay, ready? Everyone ready? And I'm not asking you to copy this down. I just want you to focus. These two line segments are congruent. All good? No big deal, right? Okay. M is the midpoint of AB, and P is the midpoint of CD. Okay. Now that you know that, are there any other line segments up there that are equal to each other other than the two original ones I had given you? Based on your knowledge of midpoint and some of your other knowledge of math here, all right, other than A, B, and CD being congruent, are there other pairs of congruent line segments up here? Maybe, maybe not. What do you got for me, Dewey? Ooh, so he's telling me AM and CP, right? MB and PD are all congruent. Everyone agree? Okay. Are AM and PD congruent? And NB and CP are congruent. So all four are congruent, you're telling me? Oh, wow. Look at that, huh? All four are congruent. Yep. And how'd you get to that? How'd you get to that thinking that they're all congruent? What'd you know about the originals? They're congruent. What's a midpoint do? Splits it in half, right? So if the originals were equal, what do you know about their halves? The halves should be equal too. The thirds, the quarters should be equal, but more specifically the halves. All right? Everyone agree? If two originals are equal, the halves have to be equal. Okay? Because now I'm going to introduce the next theorem here, which is halves of equal quantities are equal. Do you see that being applied to my line segments up there? What were my original equal quantities? What was my original equal quantities? A, B, and CD, and I took, how'd you know I took half of it? What vocabulary term did I spit at you that said, oh, half? Midpoint, right. Is there one more other vocabulary term we have out there that maybe I could have substituted? Bisect. So when we start hearing midpoint and bisects now, thinking halves, halves, halves. The halves are equal, okay? Let's get into this first proof. Okay, there's my new one. Halves of equal quantities are equal. Right off the bat, this is very similar to what I just showed you. A, B, and DC are equal. You don't need a diagram for this one. Okay, we don't need a diagram. A, B, and DC are congruent to each other. I took half of AB and I called it AF, and I took half of DC and called it EC. Wait a second. Wait a second. What do we know about what we just took half of? What do you know about AB and DC, what we're taking half of? They're congruent, and shouldn't their halves also be equal? Okay, that's what this is saying. If you take half of two equal quantities, they'll be equal as well. So this is only going to be a two-step proof. Saying that which two segments are equal? AF is congruent to EC. Halves, and you can write equals, that's fine. Halves of equal quantities are equal. Seems it's not too bad, right? If two originals are equal, their halves have to be equal. I just have to identify that I'm doing half, though. And what two words have we already talked about signify that I'm taking half of something? Bisects and midpoint. All right, now let's get a little bit more crazy. Okay, I need angle R congruent to angle S. That's my proof statement. Take a look at what I wrote in the givens for you. CA bisects, bisects, ding, 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 ding. Both DCB and DAB. Oh, hey, kids. If it's being bisected, what's happening to DCB and DAB? They're being cut in half. And not only are they being cut in half, what do you know about the two originally? Keep reading the givens. They're congruent. So if I cut them in half and they're congruent, what should I know about those halves? They should be equal, but let's write all this down here instead of talking about it. So I have DCB, the whole angle here is congruent to DAB. Got it. This is not going to be a two-step proof. Okay, this is not going to be a two-step proof. Notice in that last one we just did, I told you what half of those congruent segments were, right? Half of AB was AF. Half of DC was EC. You need to tell me that in a separate statement here. If you're going to cut DCB in half, what's it equal to now? All right. If you're going to cut DAB in half, what's it equal to now? All right. So I'll start you off here. Take one of the congruent, give me one of the congruent angles. DAB. So if I take half of DAB, that'll be equal to which new angle now? Don't yell anything out. Look at your diagram right now. Look at angle DAB. If I take half of it, everyone agree? I have two options, don't I? I have angle DAC and I have angle R to write in. Everyone agree? If I wrote either of those two angles right here, it would be correct. Which one do I care about in this proof right now? Why? It's in the proof statement. I don't care about DAC at all. I care about angle R. Which angle? R. We got pirates in here. Moving on. All right. Yep, little extra joke of the week there. Yep. We'll all go out to lunch to Arby's. Yep. Yep. Too bad we can't get into rated R movies. Yep. Moving on. Ready? We could go on vacation too. Argentina. All right, moving on. One job, honors kids. One job. All right, let's keep going. Here we go. You took half of DAB. What's the other congruent angle I'm going to take half of? Half of DCB is equal to, look at the diagram. Again, I have two choices. I can go angle DCA or angle S, but which one do I care about? S. You have to tell me you're taking half of the congruent parts, right? You have to tell me that. All right, why is this true? And it's not halves of equal quantities yet. We're not ready for that. Halves of equal quantities are when I set the halves equal to each other. That's coming up. What told me I'm taking half? I'm taking half. I'm taking half. Definition of a bisector. Got to have these half statements in here if you're going to use halves of equal quantities. Now, what can I say? I am taking half a DAB and half a DCB. So what do I know about those two, R and S? They have to be equal, or in my case, congruent. Now, halves of equal quantities are equal. I cannot stress this enough one last time. If you decide to use halves of equal quantities are equal because you see midpoint, you see bisector, you need to tell me that you're taking half of the congruent quantities and letting me know what it's equal to. Okay? Do you see the similarity between what we just did in this last one? They both have the half statements in there. Okay? All right, let me take a quick look at the homework. Make sure nothing's going to trip you guys up. I might have put a little surprise one in there. Oh, right away, I got halves, right? Okay, that one's fine. I got bisects coming up. Oh, hey, I'm just going to warn you. It's not all subtraction halves. I could have thrown a little addition in there to keep you on your toes, okay? So just don't be in the subtraction mindset. All on you guys. Go ahead, get started. I'll certainly come around and take a look at your proof if you want me to take a peek at it. Sign out, take the pad. That's it?
Yeah.
Any questions?
Nah.
Okay, thanks, man. Thanks for coming in. I'll tear the desk and chair, all right?